Hello there. In this video I'm going to be going over a lab-based question that ultimately looks for density, and along the way we are going to be using correct significant figure rounding. Okay, so first question, determine the mass of metal sample in units of grams. We've got all this data. It says mass of empty weighing boat. Empty weighing boat would be something like this. I'll put under the document camera, and it's just a container that you can stick the metal right into. That way you don't contaminate your hands or the mass or the balance that you're massing this on. Next we got mass of empty weighing boat and sample of the metal. So both of them, that's the mass. Volume of water in a graduated cylinder, and then the volume of water in a graduated cylinder when you place the metal in it. It's going to be a higher volume because of displacement. Then we have temperature of the water in graduated cylinder, which for A, B, and C, we don't really need that information. That pertains to letter D, which we're not going to get to. Determine the mass of the metal sample. Back to that question. Ultimately, we have the mass of empty weighing boat and of the unknown sample. That's 8.2150 grams, and we're going to subtract the mass of just the weighing boat, which is 2.3410. Now really, the best way to solve this would be to not only bringing your calculator to class, but pulling it out and using it. Alright, so we've got 8.215 minus 2.341 gives me 5.874 grams, and I need to carry to 4 decimal places. Least amount of decimals is 4 in this case, so I need to add a 0 there. Correct Sig Fig calculation, addition subtraction, I round to least amount of decimals, which is 4. I don't have to worry about uncertainty because I'd have to undergo a whole propagation of error. We don't deal with that here. If you want to learn about that, continue on to IB chemistry and you'll have a lot of fun. Determine the volume of the metal sample in milliliters. Alright, so we're looking for the volume. The total volume of the water and metal is 7.50. And that's milliliters. We're going to subtract the original starting volume of the water, 4.50. Alright, 7.5 minus 4.5 gives me 3. But it doesn't just give me 3. We got to round to correct Sig Fig. We've got 2 decimals. 2 decimals. We're doing addition and subtraction, so we're going to round to the least amount of decimals. So that's not just 3, it's 3.00 milliliters. Alright, then we've got letter C. Find the density. Density, remember, is just like a broken heart. You got mass over volume. So my density is mass of 5.874 grams divided by 3.00 milliliters. Plug it in my calculator. 5.874 divided by 3 equals 1.958 grams per milliliter, and they need to double check this. We've got division, so that's going to be the least amount of not least amount of decimals. When you do multiplication division, it's going to be the least amount of significant figures. 1, 2, 3, 4, 1, 2, 3. So we want to round this to 3 sig figs. 1.96 grams per milliliters would be our final answer. And that is how you do a lab-based problem.